We'll proceed in multivariate summation and integral. Okay, multivariate summation and integral. So this is more or less we are proceeding discussion into multivariate summation and integral. Multivariate summation and integral. We have done so many things as far as multivariate summation and integral is concerned. Okay, in that fashion, we will do one more exercise today. Anyway, calculating the area of a circle is still pending, but we will do something interesting. How to miss calculation of area is the only thing that we get, or we can do more in it. Can we calculate the surface area of a sphere? Many times we have calculated surface of area of a sphere through so many ways. Through so many ways. Let's try one more way. That is repeated summation to get the surface area of a sphere. So this is a sphere. So this is a sphere. What is the surface area? What is the surface area of a sphere? This is a sphere. And what is the surface area of a sphere? I don't know what is surface area of the sphere. It looks very cumbersome. It looks very awkward. Means it's not flat. If it is flat, then width into height quickly I can say surface area. What is surface area of this sphere? That is the question mark. What is the surface area of the sphere? Okay, now if people remember how we calculated the circumference of a circle, circumference of a circle. Okay, if I need to calculate circumference of a circle, how to calculate circumference of a circle? That is the question now. How to calculate circumference of a circle? In that fashion, if this is a circle, then there is a x-axis and y-axis. This is x-axis and this is y-axis. This is x-axis, this is y-axis. Circle is centered at the origin. This is x-axis, this is y-axis. Circle is centered at the origin. If it is centered at the origin, okay, is it necessary that circle is should be centered at the origin? Not required. Circle can be other places also in the Cartesian coordinate system. If this is x-axis, okay, if this is x-axis, then this is y-axis. If this is x-axis, this is y-axis. Circle can be centered at the origin. Circle can be here also. Circle can be here also. Okay, if I say circle is centered at 1 comma 1, what is the equation of circle when it is centered at the origin? In that case, equation of the circle is x minus, I'm sorry, when circle is centered at the origin, what is the equation of the circle? X square plus y square equal to a square. Okay, what people they do not see here that there is a hidden zero here. X minus 0 whole square plus y minus 0 whole square equal to radius square. What is 0, 0? This is the circle is centered at the origin. What do you mean? If circle is centered at 1 comma 1, then I'll replace 0 0 with 1 1. This is what we are saying. Now I have a circle. It is centered at 1 comma 1. What is the equation of a circle? X minus 1 whole square plus y minus 1 whole square equal to a square. That is the equation of the circle. If circle is centered at 1 comma 1, means if circle is centered at x1 comma y1, then x minus x1 whole square plus y minus y1 whole square equal to a square. This is the equation of circle in Cartesian coordinate system. Equation of circle can be seen in polar coordinate system also. R equal to cos theta. Many times we have talked about it. R equal to cos theta means radius of a circle is function over theta. When theta is changing, radius is also changing. Now consider that everyone understand radius is centered at the origin. Consider this is the origin. and this is the radius. Okay, there is one more. Okay, there is no one more. So consider this is y-axis. Now y-axis become radius here. Now when radius is growing, angle is growing, radius starts shrinking because r equal to cos theta. When theta is 0, when this angle theta is 0, radius is maximum. Now radius, when angle goes to 90-degree, radius becomes 0. There is no radius at all. Radius started from here when angle was 0, r equal to cos theta. Then as it proceeds, angle start decreasing, and when 90 degree, I'm sorry, radius start decreasing. When 90 degree, there is no radius at all. Post 90-degree, radius will start becoming bigger, 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 bigger again, and 180-degree, radius will become big again, but radius is negative. So when it starts bigger after 90-degree of angle, this start at 0-degree, then 90-degree, and then we start beyond 90-degree, radius start growing again. But radius is negative. So negative to, there is no difference between negative to positive. This is what I have always said. Negative is not separate from positive. Negative is positive only. 2 minus 3. This is wrong statement. 2 minus 3. Actually, it is 2 plus in braces minus 3. 2 plus and braces minus 3. There is nothing called negative. Everything is positive only. 2 plus minus 3 means if I say 2 plus 3, then I have to add 2 and 3. If I say 2 plus and then minus 3, I have to add 2, 2 with the 3, but 3 is in opposite direction. No. Negative means opposite direction. 2 is in opposite direction. No. In that fashion, we have radius. If radius is going beyond 90-degree and it becomes negative, then this is the radius that is going and that is negative. Opposite side is positive. So radius will start, angle is going like this, but radius will start moving like this, and it forms a complete circle. From here, then back it becomes 0, and from here it will start again and it will form a complete circle like this. This is r equal to cos theta, where angle goes from 0 to pi only. Only 0 to pi, it makes a circle rather than 0 to 2 pi. That is also a form of a circle, whatever it is. What is the circumference of a circle? If radius is moving, if I consider left side as origin, if I consider this side as origin, and this is x-axis, this is y-axis, and radius is moving like this, moving like, then it makes barrier interception on the circumference. So this is the first interception. When angle is moved, angle is growing, this is the first interception on circumference. Second, third, fourth, fifth. What are you doing? Actually, I'm trying to divide this angle from 0 to whatever maximum into n part. So in that fashion, if this is x-axis, then from here to here, this is part number 1. Here to here, part number 2. Here to here, part number 3. Like that, we have divided the circumference into n different parts, where for each part we have angle in between. This is part number I, ith part. This is ith part, and angle between it is delta theta I, delta theta I, and then there is a circumference here. Like this, if I add all circumference, consider one circumference, I denote it as as P, perimeter P. So what is the net circumference of the circle? That is summation I equal to 1 to n. Because n times we have cut this circumference, n times. Summation I equal to 1 to n, and then P, capital P, and bottom right, that is subscript I. If I add all the PI, ith section, it becomes the full circumference of the circle. Now question is arising that what is the formula, how to get ith section parameter? If I get any section parameter, and then if I same manner, okay, what are you saying? What I'm trying to say is that if I have a circle and parameter, I have divided it into so many parts. If I add all the parameter, it will become parameter of the circle. What is your ith part? parameter. Ith part parameter is parameter capital P I. That is the ith part parameter. Which looks like P1 plus P2 plus P3 plus Pi up to plus Pn will give the net circumference of the circuit. Certainly. Okay, what is the circumference of your ith section? So circumference of my ith section circle is, if this is the ith section, if this is the ith section, now from x-axis it is making angle theta. From x-axis it is making angle theta, and then ith section angle is delta theta I. What is the circumference of delta theta I angle? R into delta theta I is the arc. This is the length of circumference for the delta ith section. Oh, simple. R delta theta I. R into delta theta I is the circumference of the ith section. Can I consider that ith section circumference is R into delta theta I? Yes, you can consider like this. Okay, now I can say summation of I equal to 1 to n or delta theta I will give the net circumference. Okay, now let's start. What is R? R, consider that radius is not changing in the circle. Radius may not change in the circle. If this is a circle, radius start moving like this and radius goes like this, but radius never change, only angle is changing. If R is constant, I can take out R. Okay, in that fashion, it becomes summation of I equal to 1 to n delta theta I. Delta theta I. Now it is a fit case to convert into integration fx dx. I'm sorry, integration dx. Delta xi can be converted into dx. Integration of where I equal to 0 to n, that will get converted into theta now. Theta from 0, if my radius is constant, then I have to move full 2 pi angle to make a circle. Then theta equal to 0 to 2 pi d theta, and r outside is there, it gives the circumference of the circle. Okay, how I came to delta theta to d theta? Delta theta will get converted into d theta as per these are the things that have kind of people they have averted from the mathematics. Delta theta can be converted to d theta, and then summation I equal to 1 to n will converted into integration, and then theta equal to 0 to 2 pi. Okay, this does not make any sense at all. Integration means fx dx. Okay, integration is also fxy dx dy. Integration is also fxyz dx dy dz. Integration is also fxy dy. Integration is also fxy dx. Integration is also fxy by fy dx. Integration is also fxy by fx dy. So many integration are there. Which integration are the integration? I have talked in past video also. Integration has only one shape, that is fx dx. That's it. If you say fxy dx dy, that is in form of fxy, I can say f alpha d alpha. Makes sense? X comma y, I can say alpha. F alpha dx dy together, I can say d alpha. What is your d alpha? F dx dy can be rewritten as d of xy plane, where xy I am denoting it as alpha. So f alpha d alpha. It came in the form of again function and then d alpha. F alpha d alpha. So more or less any integration is in this form only, fx dx. If I am trying to transform any summation into integration, it must come into form of fx dx. That is extremely required. What is fx dx? If I have x-axis and there is a graph, there is a curved line that is going on top of x-axis. This is the curved line that is going on top of x-axis. Consider this is the curved line that is going on top of x-axis. Then if I say, I'm sorry, or this is x-axis, this is y-axis. There is a curved line like this that is going on top of x-axis. Equation of this curved line is fx function over x, where function over x talks about at any moment. If x equal to 2, then what is function over x? Someone has to calculate. F2, small f bracket 2, bracket close, function over x. How much it is? Depend upon what is the function over x. If it is 1 by x square, then it is 1 by 4. If it is sine x, then it is sine 2. If it is x square, then 2 square. Depend upon what is fx. What is fx pictorially? If this is x equal to 2, what is fx? Fx is the height. Every moment if I change x, height is changing. What is fx dx? Okay, fx dx means any area underneath it. If I see one area, right? I see one area. That that area whose one boundary is this line and another boundary is this line. In between it, there is one area section. Area section whose upper side, whose upper side is this and base is this. There is one area. Okay, what about left and right? That is the where from I want to calculate the area. Because if I say that there is an area whose upper side is this and lower side is this, then left and right it will span to minus infinity to plus infinity. Rather than saying minus infinity to plus infinity, consider there is a point here called A and there is a point called B. At B I have to draw a vertical. From A I have to draw a vertical. That between that two vertical, what is the area between this line and this line? This vertical and this. That is the area. That what is that area? That is area in integral calculus is limit a to b x equal to a to b fx dx. This is the meaning of integral. Integral calculus is calculation of area. Yes, integral calculus means area. What is other meaning of integral? Area. What is another meaning of integral calculus? Area. Means integral calculus is all about area only. That's it. Integral calculus is all about the area only. What is differential calculus? That is rate of change. If rate, that is how much, what is the rate of change? Rate of change. Okay, how much change I see in numerator dy by dx? How much change I see in numerator if there is one unit of change in denominator, that is dy by dx. If there is a function y fx, y is vertical and x is horizontal. In abstract term, it denotes the area. Height into width is area. Y into x is area in any fashion. But y may not be constant. It may be function over x. Still, it is area only. Fx into x, x is base and fx is height. It is again area between from where to where. Then that I describe at a limit from a to b fx dx. Anyway, we are trying to calculate perimeter of a circle. In that fashion, we have perimeter of circle is r, that is constant, summation I equal to 1 to n delta xi. This is what we have seen. Now I can multiply. What is delta xi? Delta xi, if I take delta theta I, am sorry, delta theta I, this is what we have talked. R into I equal to 1 to n delta theta I. Theta I is the angle of the ith section of the circle. If there is a circle, if there is a circle, then I divide the circle into many sections. One section, ith section, if I talk, then from center, there are two radius to it, and angle between is delta theta I. Means if I add all the delta theta, I will get the full full circumference r into summation I equal to 1 to n delta theta I. If that is the way, then delta theta. Now draw it in theta plane. This is theta axis. This is theta axis, and theta axis between 0 to 2 pi. I cut in n different parts. These explanations are not available in any of the book. Anyone can try. If this is origin, from origin I proceed like this up to 2 pi. This axis is theta axis. Now 0 to 2 pi, I cut it into n different parts. If I cut it n different parts, 0 to 2 pi, then in that fashion, we have now each part has a width of delta theta. Ith part I have a width called delta theta I. If I sum all the delta theta, it becomes 0 to 2 pi. This is what we are trying. Summation I equal to 1 to n number of sections we have divided delta theta I. Okay, now I have to bring it to integration, but this summation is summation I equal to 1 to n delta theta I is actually 2 pi. I can directly write 2 pi. 2 pi r is the circumference of the circle. Anyway, first learn how to bring into integral calculus. Integral calculus, if I have a theta, delta theta, I cannot convert into integral calculus needs two sides. Only summation of I equal to 1 to 1 I equal to 1 to n delta theta I cannot be said as it is integration d theta. This is what generally people do. Okay, it is equal to integration theta equal to 0 to 2 pi d theta. That is wrong. Integration must have two sides. It talks about area. If this is theta, then there has to be a height. Okay, x-axis and y-axis minimum it is required and maximum it is required. So consider what is height here. Function over theta is the height. There is no function over theta here. We will produce it. So in that fashion, I have, if this is theta axis, then there is another axis coming here into picture called function over theta. Now let's rewrite it. Summation of I equal to 1 to n delta theta I can be rewritten as summation I equal to 1 to n 1 into delta theta I, where 1 is function over theta, which is a constant. But still, now it came as summation of I equal to 1 to n, summation of I equal to 1 to n, and then f theta, function over theta, delta theta I. It talks about a line curve that is passing above the theta plane, and that is function over theta. Now, function over theta into delta theta, what it is? If I say this section is delta theta I and height is 1, we talk about this strip area. Now, instead of saying we are adding delta theta I as a like this, all the delta theta we are adding, now we are adding area strip, that is summation of I equal to 1 to n function over theta delta theta I, function over theta that is the height and delta theta I that is the width. Ith section area we are calculating with f theta at theta in the ith section and delta theta I. What is theta in the ith section in circular manner is, if this is x-axis, and theta is proceeding like this, then we are in ith section. So this is x-axis and this is the radius. This is angle theta, and then we are in the ith section where the in between angle is delta theta I. This is the ith section. What is the ith section angle? Theta. This is this theta we talk. Okay. So we are saying summation I equal to 1 to n function over theta, where theta is ith section theta. Okay, that theta into delta theta I. Now this is a fit case because it is function over theta. If I take theta as a straight line, then at this is first section, second section, ith section beginning, and here we have function over theta into delta theta is a giving area of this strip. If I add all the strip, then we are trying to calculate more or less function over theta underneath what is the area. That is integration. Means if I add all the strip area, it will become f theta d theta because that will become full area. Now it will become integration over theta equal to 0 to 2 pi f theta d theta, where f theta is 1, then d theta. So generally people they just write summation I equal to 1 to n delta theta I is integration theta 0 to 2 pi d theta, but that is not true. One is hidden there, that is function over theta. Anyway, it is 2 pi r. What about if radius is function of theta? Radius keeps changing. If we start from theta equal to 0, then when we reach ith section, at that time we have a radius called r1. And then I move delta theta I, radius got reduced. Because as we move on, radius is changing, like r equal to cos theta. If I move angle, radius is decreasing. So when angle was here, theta, and after that I moved delta theta I Instead of radius becoming constant, it reduced. Now, can I use now again? So, what is our the circumference fundamental? Summation of I equal to 1 to n r delta theta I. This is what we had calculated. R into delta theta I. That is the perimeter or arc of the IS section. But this may not be true if R is decreasing. Consider this is from x axis, this is angle theta, and radius moved delta theta I and it became very small. After moving delta as per the function, after moving delta theta I, radius from here, this is R1. Consider when it enters, it is R1. And then it is R2, or radius at angle theta I, and radius at angle theta I plus delta theta I. R1 and R2. There is a vast difference between R1 and R2. If I talk about an arc like this, then this arc length, when we talk about this arc length will certainly it would not be this R into delta theta I. R into delta theta I is this arc, where radius will not change. If this is the radius and the same radius proceeds, then this arc length is r r delta theta I. If radius decreases, still r or r1 delta theta I is this one. Okay, but radius is here. We are talking about this arc. What about this arc? This arc will not. Someone can try. Summation I equal to 1 to n r delta theta I. R is function over theta. So function over theta delta theta I, it is a fit case to convert into integral calculus. Function over theta, that is the height, and delta theta is the width. This is the ith section area we are talking. If I add all the subsection, we get the full area f theta d theta. Integration from 0 to pi, because we have seen when r equal to cos theta, one of the example where function radius is function over theta. If it is r equal to cos theta, then angle will go 0 to pi, not 2 pi, 0 to pi, and it makes full circle. In that fashion, integration 0 to pi function over theta d theta is the circumference. Function over theta is cos theta. Function over theta is cos theta. Cos theta d theta, that is sin theta. Sin theta 0 to pi. I believe it is 0 only. 0 is the circumference. Certainly not. 0 is not the circumference. So it is false. No. I'll divide it into 2. 0 to pi by 2 and pi by 2 to pi. I can do that, right? Let's try. 0 to pi cos theta d theta, I can divide into 0 to pi by 2 cos theta d theta plus pi by 2 to pi. Now it is sin theta 0 to pi. It will become 1 now. 1. And then pi by 2 to pi sin theta d theta. Sin pi is 0 minus sin pi by 2 minus 1 0 again. Okay, I am 100% sure that a circle that is formed by r equal to cos theta, which is like this. When this is origin, it is like this, and it is centered at 1 by 2, and radius is 1 by 2. This area is 1 by area is pi r square, pi into 1 by 2 whole square. That is the area, not 0. That is the area. Sorry. What is circumference of the circle whose radius is 1 by 2? 2 pi r. 2 gone. Pi. Pi is the circumference. Okay, but here it is coming as 0. So this fundamental is not correct, because the arc we have taken, r into delta theta I, is this arc, but radius reduced. As we proceeded in angle, radius reduced. We are talking about this arc now. Ith section arc is this, not this. How to get this arc? To get this arc, this is x-axis, this is y-axis. I have to get this arc fundamental in a way that this arc way of calculation like this or this should be same. Now in that fashion, if I see from here to here, there is a change in x, and from here to here there is change in y. Consider change in x is delta x and change in y is delta y. If I say delta x whole square plus delta y whole square root, then it gives me a arc length which is a straight line. I can transform into a triangle. Triangle means if this is the x-axis and it made theta angle. This is delta theta I. delta theta I section where this is the arc. Now, if radius moves from here to here, then top of the radius if I take and this is the arc, from here to here it moved delta x. From here to here it moved delta y. Now, if I say delta x whole square, delta plus delta y whole square, it is a triangle it is showing. Then that is equal to the hypotenuse, but it should be a straight line. All right, I can take a straight line because delta I is very small. Now we have ith section ith section arc length where the ith section delta theta I is very small. Then it is delta x whole square plus delta y whole square root. Make sense? Okay. Now I can rewrite it summation I equal to 1 to n square root delta x of the ith section whole square plus delta y of the ith section whole square. That's it. That is the arc length of ith section. What if radius is not changing? If radius is not changing and this is the arc, still we have delta x and delta y, and this is the arc. This is more generic now. We have found it. Now we have summation I equal to 1 to n square root delta x of the ith section whole square plus delta y of the ith section whole square. Now someone can try, proceed upon it, and he will get the circumference of the circle. Okay, how to get the area? How to get the area of this surface area of a sphere? Actually, the actual discussion is how to calculate the surface area of a sphere. For that, we brought that much discussion. If I talk about surface area of a sphere, okay, then if I take any point on the sphere, consider this sphere is centered at the origin. Means center of this sphere is origin, that is 0 comma 0 comma 0. Okay, then from origin everywhere if I compute the length, it is radius, that is a. Sphere radius will go in omnidirection, not only in one plane. It will go in xy plane, it will go in yz plane, it will go in xz plane, it will go in zxy plane. Everywhere radius will go in omnidirection, and consider that length is a. I have to find the surface area of this sphere. Consider any point P here. Means if I take xy plane will cut at the middle and top of the sphere, that is top hemisphere, that is above the xy plane and one is below the xy plane. Now from the center of it, I draw a straight line and hit here. Okay, that is the radius of the sphere. Okay, in that fashion, consider that point is P. That point is P. If point is P there, then at point P, I draw, okay, there is a point P on the surface. Consider this is point P. Let's cut this point P in the, oh, I believe that will be again tedious. Okay, in simple manner, just think that at point P, I move in a line. At point P, I can move a line where y is constant. Makes sense? If there is a point P here, and I draw a line passing through point P where y is constant, x is variable, this is x-axis, this is y-axis, this is z-axis, height is z-axis. Now there is a point P here, and I draw a line like this, and this line is passing point P, but all the while I make sure that y is not changing, only x is changing and z is changing. Makes sense? Then there is a line, that line is an arc of a circle, because this is a sphere. A sphere means complete round. If I draw a line and then goes like this and it come back to the same point, it is a circle. I'm trying to draw a circle that is passing point P, but y is not changing. I'm trying to draw, then what is the, now that circle I cut into n part. Makes sense? That circle, I cut it into n part. What is the length of the ith section? Now we have delta x and delta z. Y is constant. In that fashion, the length of the ith section is square root delta x ith section whole square plus delta z ith section whole square. That is the ith section length of a circle that is passing point P. P is x comma y comma z. These explanations are not available in any of the book. Anyone can try or internet wherever. Now that is the length of the, if I make a circle like this where y is constant and I cut it into n part, then ith part length is delta x ith part whole square plus delta y ith part delta z ith part whole square root. There is no y come into the picture because y is constant. In that fashion, that is the length of the ith section. What about I take another circle where x is constant and I draw in YZ plane, someone can tell me. I draw, if this is the point, I draw a circle like this and it comes to the same point. If that is the case, then it passes through P, and at that moment, if it passes through P, where X is constant, and I cut that into N part, okay, then ith section where P belongs to. Here also ith section where P belongs to. There ith section where P belong to. The length of this line, the arc of the ith section is delta y, or consider, okay, let's say ith section 1. Delta y ith section whole square plus delta z ith section whole square root. Make sense? Okay, if on the sphere, if I draw a line connecting point P, I have taken one hypothetical point P, x, y, z, and if I draw a line, make it full, that is a circle, and that circle, if I cut into n part, the ith section part, the arc is delta x ith section whole square plus delta z ith section whole square root. Same point, I make a line again where x is constant. Earlier y was constant. Now x is constant. X axis, y axis, and z axis. If I draw a line like this, I cut into n part. Then what is the ith section arc length? Consider P falls in the ith section. Then that arc length is delta y ith section whole square plus delta z ith section whole square root. Okay, now at point P, what is the area of the ith section? Ith section belongs to this circle and ith section belongs to this circle, and their P falls. If two circles they cut each other, at point P, then we have two arcs. At point P, one arc is in xz plane and one arc is in yz plane. I believe it is all right what I'm trying to demonstrate. Okay, if this is the arc, that is in, this is xz plane, y is constant, this is the arc, this is point P. Now yz plane, this is the arc and this is point P. If I connect this line and make it around there, it forms an area. Makes sense? If there are two sides cutting each other, then if I connect end points, this point and then this point and then this point, because this is the arc from here, look, from here to here there is one arc, and from this line from here to here there is one arc. If I connect this point and top of this point and this point and this, then it forms a circle area. What is that area? That is the area of the ith section. Make sense? Now we come in another fundamental law. What is that fundamental is? Summation I equal to 1 to 1 AI is the net surface area, where AI is the surface area of the ith section. Makes sense? I equal to 1 to n, because both are cut into n parts. I equal to 1 to n, and then AI, where AI belongs in this fashion. Then it is the surface area. What is the AI? AI is the length of this section multiplied by length of this section. That is under question mark. Consider like that. Okay, what is length of this section? That is square root delta xi whole square plus delta z whole square. And what is that one? Multiply. Consider it forms a rectangle. Then another is square root delta y I whole square plus delta z I whole square. Now these two, if I multiply, I've taken everything in simplest form. If I multiply, I get the ith section area. Now that area, I have to keep adding for all the section, I get the surface area. Okay, now how I can proceed now? Consider what is delta x plus delta z whole square root. What is that? Hold on. It looks like this is magnitude of a vector. What vector are you talking about? That is delta xi plus delta zk. If I have a vector and if I calculate the magnitude, it is exactly like that. Delta xi plus delta zk. If I calculate the magnitude of this vector, that is delta xi whole square plus delta z whole square root, means now I can rewrite as magnitude of a vector delta x whole square, I'm sorry, delta xi plus delta zk magnitude into, and then another is delta yj plus delta zk vector magnitude. What is delta xi plus delta zk? Okay, now same thing the way we applied, what is delta theta? Delta theta is same as 1 into delta theta. Means more or less I can reconsider it as a area of a strip. In that fashion, delta theta, delta xi plus delta zk, I can rewrite as d d of xi plus zk. Makes sense? Delta I kept out, or delta, and in bracket xi plus zk, delta xi plus zk. Okay, in that fashion, delta I, where z is function of x and y, but here we have taken y as constant. If that is the way, then I can rewrite as delta I'm sorry, summation delta, and in bracket xi plus zk into into again the magnitude of delta, and in bracket yj plus zk. Now here if I see the first part, then I can divide it by delta x and multiply it by delta x. Who is stopping me? Anything I can divide by an amount and multiply by the same amount. Now it becomes a delta, and in bracket delta means magnitude of delta, and in bracket xi plus zk by delta x. Okay, and then into magnitude of another amount where delta, and in bracket yj plus zk by delta y. And here I have to multiply with the delta x, here I have to multiply with the delta y. Same thing. Magnitude of delta xi plus zk is same as magnitude of delta xi plus zk by delta x into delta x. There, magnitude of delta yj plus zk by delta zk is same as whatever we said by delta y into delta y. Now delta x and delta y I can keep outside. Now it becomes a delta xi plus zk by delta x. Okay, it is same as delta xi plus yj plus zk by delta x, because y is constant, and in term of delta, if I say dy, I'm sorry. Okay, now if it is delta xi plus zk by delta x, now the way we have said I can multiply with the 1, there also multiply with the 1, it will become area of a strip. In that fashion, now it is a fit candidate to be converted into integration. So it will become d of xi plus zk by dx. Okay, in that fashion, by dx into dx. If that is the case, then it becomes I plus dz by dx k. Or if I still talking in delta, then it will become I plus delta z by delta xk magnitude. Makes sense? Okay, I can write here same I plus delta z by delta xk is same as I plus delta y by delta xj plus delta z by delta xk. Where from you brought delta y by delta x? Because y is constant. So delta y by delta x will be 0. Change in x, there is no change in y. 0. So 0 I can place in addition, no problem. So it become, now if my expression become I plus delta y by delta xj plus delta z by delta x k. Now again I take out delta. Now it becomes delta delta xi plus yj plus zk divided by delta x. Xi plus yj plus zk is position vector of point x comma y comma z. It's a vector. Now it becomes delta p by delta x magnitude into there also delta p. There I brought delta x. I introduced delta x. Delta p by delta y magnitude into delta x delta y. Make sense? Okay. Now we have two vector p delta p by delta p by delta x, and I have another vector delta p by delta x. If numerator is dependent upon denominator, means change the position vector will change if I change x. If that is the case, then we change it into the differential calculus. And if numerator, so this will become dp by dp by dx into dp by dy. Okay, if that is the case, then dp by dx, this scenario, it arrives dp by dx, dp by dy, dx dy. If I cut it again, then it becomes dp into dp. Makes sense? Let's cut delta x, delta y, because we had introduced delta x, delta y. Now cut it. No delta x, no delta y. It is magnitude of delta p into delta p. What is delta p? Delta p is the arc length in the xz plane where y was constant. And delta p, another delta p is arc length in yz plane where x is constant. In that fashion, if you really want area, then this delta p is a vector. And that delta p is all again a vector. If I want area in between, that is ith section area, I have to use cross product. If I have a line like this, if I have a line like this and another line like this, if I want area, I can directly multiply it because it forms a rectangle. But if line is a curve and another line is also curve and I want area, then this, if it is if it is very small, consider this is like this only straight line. I'm taking approximation, still I want to calculate area. Generic ways, I have to take cross product of these two vectors and it will give the area. So in generic fashion, because it may not be that it will cut at right angle only, it may form a parallelogram also. So generic way of calculating the area between two vectors is do cross product. Now again we rewrite what we had written. Delta p by delta x magnitude into delta p by delta y magnitude delta x delta y. It will be transformed into dp by dx cross dp by dy dx dy. Make sense? Okay, in that fashion, if people are very curious, then they can rewrite it like this. Delta p by delta p by delta x, it will come as delta p by delta x will come as a vector only, and that magnitude. Cross product delta p by delta y, okay, magnitude. It will can be rewritten as delta p by delta x cross product delta p by delta y magnitude delta x delta y. Delta x delta y I can rewrite as delta xy. Xy is a plane. Delta xy plane. Now it is now in a form of full-fledged function over something into whatever it is. Now independent component, if I take it as xy plane, then right side we have dxy plane, and dependent component is function over xy plane, that is delta p by delta x cross product delta p by delta y magnitude. This whole is a function over xy plane and then into delta xy. Ith section, summation I equal to 1 to n. This is a fit case to transform into integral calculus, because we have delta of something, that is the ith section, and then we have a function over that something. It is a fit case. The way we had converted delta xi into 1 into delta xi, I'm sorry, delta theta I into 1 into delta theta I, where 1 was considered as a function over theta. Summation f theta delta theta I is a fit case to convert into f theta d theta, because it is talking about area of the one strip. If I add all the strip, it becomes the f theta d theta. Similarly, I have summation I equal to 1 to n, and then I have one magnitude delta p by delta x ith section cross product delta p by delta y ith section in others two circle we had made. This full is a function over xy plane into delta xy plane ith section. Now we have this will give a, if I this is xy plane and this is function over xy plane I'm considering as one axis only, and this is function over xy plane, then this is the area of the ith strip. If I add all the strip, it gives me the full area, that is function over xy plane d function over xy plane integration. Okay, now integration side limit in the xy plane from one location to another location, and then function over xy plane, that is magnitude dp by dx cross dp by dy and dxy plane. If I proceed in this, will it give me the surface area? Okay, take it as an assignment now. dp by dx cross dp by dy magnitude d of xy plane, where limit is in xy plane one location to another location, will it give the surface area? Okay, because we proceeded in that fashion, we will do it in another session. So this is the assignment to the students. Means they would not try that calculating this will actually it will give the surface area. Okay, that we will see. Please do not mind. These are not available in any of the book. I'm pretty sure about it. So please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.